Just kidding. All right, Math 8, April 20th. Let's go. Okay, last thing we did was the assignment, and we're going to correct the reteach worksheet 12-1. So let's go to that. And we did 2 and 3. Hope you're watching those Math Antics videos, because they are good. Okay, so they gave us A and B on number 2. Let's find C. We plug in what we know. We know 8 and 15. So we squared them. 8 squared, 15 squared, add them up. Uh-oh, square root of 289. What do I do now? Oh, okay. Let's go to my little chart. I know that it's 17, but let's see how I got there. 289 sits in between 225 and 400. Okay, 225 is 15, and 400 is 20. Let's see what we got here. Okay, from 225 to 400 is what, 175? 225 to 289 is, what is that, about 64? So we're less than halfway there. Let's see. So I know that it's between 15 and 20. If it's a whole number, if it's a perfect square, we're going to end up one of these numbers. So if you remember my little shortcut that I got somewhere, I hope I'm not taking credit for something I didn't come up with, but anyway, if you take the first one and you square it, 15 times 15, 5 times 5 ends in 5. 16 squared, 6 times 6, it's going to end in 6. 17 squared, it's going to end in 9. 7 times 7, 49. That looks like the answer, and it is 17. So without a calculator, without a chart, we're coming up with a way that we can come up with the answer for this. That's a nice little way to do it. Okay. Let's try number 3. Okay. They gave us B and C, and we need to find this one. We need to find A. Okay, plug in what you know and go from there. B is 24, C is 26. Square them. That's what the theorem tells us to do. So we're squaring 24 and we're squaring 26. Now you have an equation and you want to get A by itself. To get rid of the 576, you subtract it from both sides. These two go away. And you've got A squared equals 100. Square root of both sides. A equals 10. Okay, they gave us an easy one. All right, that was the reteach worksheet. Remember, if I'm going fast, it's because you can stop the video and you can check it out. Okay, let's go to the other worksheet. And we did, what, 1, 2, 3, and 6? Okay, let's take a look here. This one, we did this, we estimated. Not a lot of fun, but let's go over it just for a goof. That's why I married her. Okay, you ready? She's sitting about 6 feet behind me. She's going to bounce something off my head. All right, so we plugged in what we know. Hope I'm not making anybody seasick here. We know that, I thought I crossed these out. We're going to call either one of these A and B, and we're finding C. Okay, so we plug them in. Remember, A and B don't matter as long as you always have C in the right spot. Okay, that's the longest side, remember. Okay, so 5 squared plus 4 squared, that should be 41. Uh-oh. That's not a perfect square. That's irrational. All right, let's do this. Taking the square root of both sides. 41's not a perfect square. Arrow tells me to go over here. It can't be good. So I've got this mess. 36 is a perfect square, and so is 49. They're consecutive integers, 6 and 7. So 41 sits in between 6 and 7. Square root of 41 sits in between 6 and 7. So from 36 to 41 is 5. From 36 to 49 is 13. So it's 5/13 of the way there. 5/13 is less than a half. Half of 13 is 6 and a half. And we're less than that. So we're less than halfway. I put my numbers between 6 and 7 going by tenths, 6.1, 6.2, etc. And I put a little line there saying that it's going to be over here somewhere. Well, it's kind of close to half, so it's probably in this range here. So then you got to start squaring some stuff. Remember we did this? If I had a number line, it would look like this. From 36 to 49 is plus 13. From 36 to 41 is 5, so it's 5/13 of the way. And then we say, all right, let's start squaring some stuff. So I took 6.4 and 6.5. And when I squared 6.4, it becomes 40.96. And when I squared 6.5, it becomes 42.25. So then I want to see which one is it closer to, because the number we're looking for is 41, and it sits in between those two numbers. Well, if we're talking about money, the first two here, it's only 4 cents away. It's 0.04. If I go from 41 to 42.5, that's $1.25. So we're only 4 cents away. If it was money, I'd say it's closer to 6.4, and that's my answer. Because 6.4 squared gets me closest to 41. Very close. It's only that far off. That's a good number. Okay, so then my answer would be, it's approximately 6.4. And that's good enough. Make sense? Alrighty then. Let's look at this one. Okay, that one's going to be C. That's the longest side, the hypotenuse. And since that's B, that's going to be A. So we know that A is 15 and C is 25. Let's find B. Okay, let's go over here. Nope, this way. We're plugging in what we know. We know C and we know A. Hopefully you remembered these. 15 squared is 225. 25 squared is 625. If you memorize them, you can just pull from your brain and not from having to write it out or get a calculator. Okay, so we've got the next line down. We've got an equation. We want to solve it and get B by itself. How do I do that? Well, let's get rid of 225 by subtracting it from both sides. These two are gone. My next line down should be what? B squared equals 400. And if you've memorized that, square root of both sides, B equals 20. All right. More fun than a barrel of monkeys. Let's go to number 3 up here. I thought I already crossed these out. I think I erased something and they all came back somehow. Anyway, there's A. We know that's C, and we know that's going to be, by default, B. They gave me B and C. Find A. All right. Okay, so plug in what you know. In this case, find A. 60 squared, 6 times 6 is 36, add 2 zeros, 3,600, and 48 squared is 2304. Now you got to get a by itself, so 2304 has to go. Subtract it from both sides, do the opposite. These two go away. It's the additive inverse. All right, a squared equals 1296. And if I'm going to do it by hand, I'm going to go, all right, on my chart, where's 1296? Well, 1296 is somewhere in here. It's in between 35 and 40. If it's going to be a perfect square, it shouldn't be too hard to find. I'm going to list a perfect square on each side, 1225 and 1600, which is 35 and 40. What's in between 35 and 40? 36, 37, 38, 39. If this is a perfect square and it ends in 6, if I squared 36, 36 times 36, it ends in 6, that's going to be the answer, 36. That's what we had right here. If it's not, and you had to do it by hand, that's when you got to start squaring some stuff. And that takes longer. Okay, let's do number 6. I skipped some of these that were a real pain in the keister, so let's go here. On this one, they gave us C and A, find B. 78 squared equals 900 plus B squared. So 84 equals 900 plus B squared. Get rid of the 900. B squared equals 5184. I was estimating, saying 78 is close to 80. 80 squared would be 6400, so it's somewhere a little bit less, which it is, 5184. Okay, square root of both sides. And we're going, wow, that doesn't look familiar. Let's go to the chart. So we go to 5184, but the problem is, that's way bigger than my chart. So I'm going to just extend the chart. 40 squared, 50 squared is 2500. 60 squared is 3600. 70 squared is 4900. 80 squared is 6400. So 5184 sits in between these two, between 70 and 80. And if it's a perfect square, we'll be able to find it. Okay, so you come over here, and we say that it's between 70 and 80. And since we didn't know, before we were going by fives over here, 10, 15, 20, 25. Here we're going by tens. No big deal, just it's a bigger area to look for the number in between. Okay. So I put all these numbers here, and I said, okay, it ends in 4, so what times what gives me 4? 1 times 1 is 1, ooh, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, and if you look here, you can see that it's 284 from here to here, and it's 1500 all the way over here. So if it's 284 over 1500, 300 over 1500 would be 1/5, that's 0.2. We're close to here. We're not going to be way down over here. We're going to be closer to 70 than 80. And you can see my answer is 72 because none of them work out anyway. 9 times 9 ends in 1. So 72 is the answer. And if you check it by squaring it, you get the actual number, 5184. Okay, we've corrected the 2 worksheets. Let's go to page 384 and see what's going on here. Okay. When they give you two sides, use the Pythagorean theorem and you find the third, the missing side. No problem. If they give you all three sides and they say, hey, is that a right triangle? And let's say the box wasn't here. Is that a right triangle? You go, I don't know. How do you find out? Plug them in. Plug in all three sides. You have 9, 40, and 41. See how they plugged all three sides in here? Then do the math. 9 squared, 81. 40 squared, 1600. 41 squared, 1681. Do the math, add these up. Oh look, they're equal to each other. Yes, it's a right triangle. If the left side equals the right side, yes, that triangle is a right triangle. Here they gave you 8, 10, and 12. Plug them in. 8 squared, 10 squared, 12 squared. Look, the left side does not equal the right side. Not a right triangle. See right here, the triangle is not a right triangle. Using the converse. Use the converse. Why don't they use the Nike or the Adidas of the Pythagorean theorem? If they don't, they use the converse. I don't know why. Maybe they have a contract with them. I'm not sure. Okay, so in here, you'd be just doing the math. The good thing to notice is you got 14, 23, 25, 16, 30, 34, 27, 36, 45, 11, 18. They're all in order. Sometimes they put the hypotenuse over here, on the left side over here, and they fool people, and they mess up the whole problem. So let's take a look at number 2 here. If I do the math, take these three numbers, plug them in, make sure the biggest number is over here where the hypotenuse goes. Plug them in, do the math. Nope, not a right triangle. On number 3, make sure the hypotenuse is the longest side over here because a squared plus b squared equals c squared. Do the math, square everything, add them up. Yep, it's a right triangle because the left side equals the right side. That is a right triangle. On number 4, do the math. Yep, it's a right triangle. Left side equals the right side. And on number 5, same thing. Not a right triangle. 445 does not equal 441. Okay, let's move on here. Page 385. We've already done that, using the converse Pythagorean theorem. They plug all the stuff in here, they do the math, and it's not a right triangle. I think I'm going to retire and become an artist. That is top notch right there. That's Mr. Pigface, I think. Looks like a snout. Okay. Here's what I was going to show you on this one. It says, a blueprint for a new triangular playground shows that the sides measure blah, 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 blah. Okay, look what I did. I took the 0 off on each one of these. It's like you divided them all by 10. And here's the deal. The one up here is just 10 times bigger than this one, but it's the same ratio. So you could, if you had to do this by hand, you could divide each of them by 10 and just take 48 squared plus 14 squared equals 50 squared, and you'd end up with, they're going to get 250 over here. We'd end up with a smaller number. Make sense? It would still work. The ratios are the same. It's just, the ratios work, in other words. They're not this, it's a 10-to-1 ratio. If I could spit this out. There we go. Okay. Instead of doing this stuff is more confusing than it is helpful. Watch these videos. I wrote in the notes that I joined so I can get access to their worksheets, and they have a video explanation of their worksheets. It's pretty good stuff. Okay, on here. We're on page 387. You're saying, let's see, is it a right triangle? The answer is yes or no. I'm always checking to make sure the longest side is C. The longest side is C. Same here, same here, same here, same here. On number 9, same thing I did on the other one. I divided everything by 10. 20, 30, 40 becomes 2, 3, 4. It's just going to be it'll be a triangle that's 1/10 of the size, but it still works. When you get to number 14, here's what I was telling you to watch out for. See what they did? They put 25. Most people would just keep going and go, all right, 25 squared plus 14 squared equals 23 squared. And the longest side is the hypotenuse in a right triangle, and see how the longest side is over here, and it should be over here. So I put out of order. It's not going to work. Make any sense? I hope. All right. And over here, it's just yes or no. It's a right triangle or it's not. Left side equals the right side. It's a right triangle. Okay, I'm trying to keep this a manageable number of minutes. So let's see. Let's go to the workbook. We're doing 1, 2, 4, 8, and 9. So they want you to write yes for sides that form a right triangle and no for sides that do not form a right triangle. Prove that the answer is correct. Do the math. 7 squared plus 24 squared equals 25 squared. Solve it and see if the left side equals the right side. If it is, yes. If it's not, no. On number 8, I gave you guys a hint here. I drew the triangle from the rectangle for you. And then number 9, you got to do a little bit of thinking. All right, so I'll be sending out another video on Wednesday. Make sure you get this done. We'll go over it, and then we'll see what happens. All right then, that's it for today. Is my assistant back there sleeping?
Yes, I am.
Okay. I'm not going to pay you. Wait, I don't pay you. That's right.